have a bunch of reading to do. If I don't make this and like throw it out there, it's just never gonna exist. Take 3, let's try it. Hi. I just finished Algorithms to Live by Brian Christensen and Tom Griffiths, and it's amazing. It has a bunch of really interesting real world applications. Like, you could read this thing as like a decision paralysis self-help book if you wanted, but you could also read it as a computational philosophy book, or you can even read it as a philosophy of technology book. Like, there's so many different ways to read this book. It's really well put together. It's very well written. The examples are awesome. Thank you so much, Brian and Tom, if you ever see this, for making it. It's awesome. My main goal in this video is not to make a point-by-point analysis of everything that happens. What I really want to do is I want to look at a couple of examples, hopefully just one, and then look at the implications of this understanding of how computation works for the question of artificial intelligence, the question of singularity, and the question of transhumanism in terms of our merging with technology. Computers do. That's the wrong... There are problems in computer science that are called hard problems, and hard is not just means like challenging. In computer science terms, it actually means impossible to solve. They go into details around like non-polynomial time or different ways of explaining precisely why this is the case. I don't want to go through that here, but there are computations that computers simply cannot do. And that strikes me as odd, because the way we tend to look at computers is that computers have a sort of objectivity in their calculations. You feed a problem to a computer, and then the computer just sort of churns and churns and churns and turns and turns, and then boom, it hands you the objective answer. We're used to doing this. Google, tell me how I'm supposed to get to this everything. Tell me what this answer is. Computate this. You know, calculators. We think of computers as like sophisticated calculators, in that they don't have to. They don't make a lot of mistakes, and they don't have to make considerations for like uncertainty and things. But computers are not being used as calculators anymore. Computers are being used to solve what's referred to in computer science as hard problems. So a classic example of that that's in the book is the traveling salesman problem. A salesman has to get to a bunch of different towns, and for the sake of maximizing the salesman's time, he wants to only go to each town once. What's the maximum? How does he go the most efficient route to get there? And it actually turns out this is a really hard problem to solve. Not hard in like challenging, computationally impossible. And it's not theoretical. It's a problem that really happens in actual industries. Like the Postal Service has to solve this problem, and airlines have to solve this problem. And Amazon has to solve this problem for like how to send its robots through its warehouses to pick stuff up from shelves. So the takeaway from the traveling salesman problem is that you can, in theory, compute a like ideal answer. But when you actually stick a computer on trying to solve the problem, it takes thousands of years to find the right answer, because there's trillions and trillions and trillions of possibilities for how to move through a series of towns. So computer scientists, like, they're not going to just turn to the US Postal Service and say, we can't calculate it, sorry. They have to make concessions on the problem, and if they make concessions, they lower the constraints, they make it easier, then maybe the truck gets to drive past the house twice, or the salesman gets to go to a town twice. But by relaxing the constraints, by being less idealistically objective about how the problem gets solved, is in fact the only way that computers can make progress on a problem. And the reason that I think this is super important is because we, in this moment in history, kind of put technology on a type of pedestal. And I don't mean that in like a worshipping like sort of sense, but we think of the results that computers give us as somehow objectively valid in a way that other methods of determining the truth aren't. And the reason that that's super important for the transhumanist camp and way of thinking is part of what drives this sort of visceral desire of some people to like evolve beyond our human limitations into a technologically integrated way of being, is because we think that if we were to do this, then we would become kind of more like gods than we are right now. And this is evident in the way a lot of transhumanists present their cases. And if you don't believe me, like, look at the movie Lucy. Actually, don't. It's not that good. But also, it's in the movie Lucy, spoilers, sorry, she becomes increasingly integrated with technology to the point where she transcends time and space and like becomes a god. And also, and I should say on a less like philosophical note, people tend to also think that technology as will save us. We look at people like Elon Musk and Solar City, and we say like, oh, you know, global warming, technology will solve that problem. Technology created that problem, but we're like, oh, technology will solve that problem. There's all these different ways where we turn to innovation and we say technological innovation is going to solve our problems. The thing is, though, if you look at actual computers solving actual problems, that's not how it really works. That's not what computers do. That's the wrong vision of what technology is. And maybe we'll develop advanced technologies in the future, but the idea that those advanced technologies would somehow transcend the limits of rationality itself doesn't make any sense at all. And so here's what I want to propose to you. Computers limit the amount of information that they use to make a calculation. They have a finite amount of information with which to work. They have a finite number of, those are the same, sorry. Computers have a finite amount of information with which to work. They have to relax the constraints of a problem in order to actually solve or even get close to getting solved a problem, like in the case of the Postal Service and the traveling salesman. And in so doing, they show us that to solve real problems, i.e. hard problems, actual problems in the world, computers aren't on a sort of privileged epistemic status. They don't have that. They're just computational tools, kind of just like our brain is. And there's a line right at the end that talks about a bunch of really cool stuff. And again, like please read this book. If nothing comes from this video except you reading this book, it will have been a success. Okay, so indeed, people are almost always confronting what computer science regards as the hard cases. Up against such hard cases, effective algorithms make assumptions, show a bias towards simpler solutions, trade off the costs of error against the costs of delay, and take chances. These aren't the concessions we make when we can't be rational. They're what being rational means. So, glossing, trying to keep this video short, being rational means relaxing your constraints, not being completely objective about every single problem that you have. Like, looking at a hard problem and trying to solve it even though you know intellectually that there's no computational response. A lot of transhumanists and futurists and technologists, look at technology as the thing that's going to transcend our limitations of rationality. But that's not the case. A computer is a machine that has finite computational resources. Merging with computers might make us more computationally savvy, but it's not going to turn us into gods. Okay, please read this book. I'll put an Amazon link down below. I don't have enough people on my channel to make money if you click my Amazon links, but maybe in the future. Check out this book, it's really good. If you're new to the channel, I have I do philosophy vlogs where I talk about stuff that I'm reading. Part of the motivation for doing that is that the more that I talk about the stuff that I'm reading, the better I understand it. And why would I talk to like a thin air or like the voice memo app on my phone or like friends that don't want to listen if I could talk to someone who like might actually be interested. So if you found this video, hope you enjoyed it. Hit the like, hit subscribe, and check out more videos coming soon. All right, have a good night.